So far we've been looking at arithmetic sequences, and one of the key features, or in fact the key feature of an arithmetic sequence, is that the terms, consecutive terms, have a common difference. We can work out what that common difference is by subtracting consecutive terms from each other. We're moving on to the next type of sequence, or the other type of sequence, which is what's known as a geometric sequence. This one is a geometric sequence, has a common ratio. So to get from one term to the next term, we don't add or subtract anything, we actually multiply by something, and hence the term common ratio. The general formula for the nth term is Tn. So A is our first term, and this time R is our common ratio, and Tn equals A times R to the power of n minus 1, where n is the term number. Over here we've got a small example and just another description. A geometric sequence is one where to get from one term to the next, you multiply by, hence notice the emphasis on multiply. You multiply by the same number each time, and this number is called the common ratio. You can see in this example that to get from 2 to 10, if you were thinking it was an arithmetic sequence, you would go, oh, well, 2 to 10, that's plus 8. But to get from 10 to 50, that's plus 40. And to get from 50 to 250, that's plus 200. So clearly, it's not an arithmetic sequence. Because the difference is not common between each pair of terms. We work out the common ratio in a similar fashion as we would work out the common difference, and we start with the last number. So 250 divided by the previous one divided by 50 gives us 5. 50 divided by the previous term, 10, gives us 5. 10 divided by the previous term, 2, gives us 5. And so you can see that the common ratio, and when we're talking about common ratio, we're really talking about a common factor, I suppose, but it is referred to as a ratio, not a factor. The common ratio, R, is 5, because to get from one term to the next, we multiply by 5. All right, let's have a look at the example number 8 when the screen catches up. Okay, so for the following sequence, show that the sequence is geometric. Remember, a show question, you just use the numerical values. Start with the last term, 48, divided by the previous term, 24. 48 divided by 24 is 2. Then we go 24 divided by its previous term, which is 12. 24 divided by 12 is 2. We go 12 divided by the previous term, 6, that's 2. And 6 divided by the previous term, which is 3, I beg your pardon, gives us 2. Therefore, consecutive terms have a common ratio. It happens that the common ratio is 2, but it doesn't have to be 2, obviously. Therefore, sequence is geometric. Okay, you need to show the common ratio, you need to make a statement about the fact that consecutive terms have a common ratio, and then you can conclude that the sequence is geometric. All right, find the general term Tn. So remember, Tn is our initial term multiplied by our common ratio to the power of n minus 1. So in this example, Tn is going to be our first term, which is 3. So A equals 3, R equals 2. In this case, we've just calculated in the previous example. So it's 3 times 2 to the power of n minus 1. And we can leave it at that. Question C says find the 7th term. So we're letting n equal 7. So the 7th term, T7, is going to be 3 times 2 to the power of 7 minus 1. which is 3 times 2 to the power of 6, which is 3 times... Now, BOMDAS rules tell us evaluate this 2 to the power of 6 first. Check on your calculator. 2 to the power of 6 is 64, and then 3 times 64 is 192. So T7 equals 192. Please be careful with your handling of the index. I'll show you a common error. A common error is to say 3 times 2 to the power of 6 equals 3 times 2 is 6 to the power of 6, and 6 to the power of 6 is whatever it is. 6 to the power of 6 is 46,656. So the mistake there is doing this multiplication first. You must evaluate the index first according to BOMDAS rules. And that's it.